Today's daily code video problem of the day is prime subtraction operation number 2601. For this problem, we're given a zero-indexed integer array nums of length n, and we can perform the following operation as many times as we want. We're going to pick an index I, which we haven't picked before, and pick a prime number p, which is strictly less than numbers of I. Then we're going to subtract p from nums of I. We want to return true if we can make nums a strictly increasing array using the above operation, and false otherwise. Strictly increasing array simply means that it increases from left to right. So for this problem, it's important to know that a prime factor number is a number that cannot be divided by anything but itself. Numbers like this are 1, 2, 3, 5, 7, 11, so on and so forth. So for this problem, our approach is going to, first we need to generate a prime number. And this number needs to identify as a prime, which means it can only be divided by itself, and it also needs to be less than nums of I. We'll then iterate through our array, and for each element in nums, determine the largest possible prime number that can be subtracted without making the element non-positive and greater than the element that's before it. We'll then subtract the prime and check for strictly increasing order. So we'll just loop through and do that. So let's go ahead and jump into the code. First thing we're going to do is identify a function to check if a number is prime. So we're going to call to a helper function. This helper function will be called isPrime. So public boolean is prime, and then it will be passed an integer x. And in this helper function, all we need to do to determine if a number is prime is simply check if it has a square root other than itself. So if x is less than or equal to 1, we can return false. Otherwise, we'll loop for int I is equal to 2, as long as I is less than or equal to math.square root of x, I++. And we're going to check to see if x modulus I will ever be equal to 0. So we're checking to see if a number divided by another number is ever equal to 0, then it is not a prime. Otherwise, it is a prime. So that is it for our identifying a prime. Next, we are going to define our prime subtraction operation. So for this, we're going to simply loop through our elements, identify a number we're going to subtract from it, and then subtract that number. So for int I is equal to 0, as long as I is less than nums.length, I can increment. If I is equal to 0, then bound is equal to nums of 0. And we got to make sure that we actually initiate that variable. Sorry. So we're going to have integer bound. And then we're going to check otherwise, else bound is going to be equal to nums of I minus nums of I minus 1. So as long as there's a number previous to it, we can subtract it from the other number, and that is to find the largest prime that keeps nums of I greater than nums of I minus 1. So this is just strictly checking to see what the greatest prime number is without either going below 0 or going below the previous element. Next, we are going to check if bound is greater than or equal to 0. So if bound is less than or equal to 0, we can return false, as the elements are if bound is less than or equal to 0, we have no way to make it make the function strictly increasing, because we do not have a number that we can subtract to make it fit within our rules. But if bound is not less than or equal to 0, we can identify the largest prime, and then we'll subtract that. So int largest prime is going to start out as 0 and 4. Int j is equal to bound minus 1. As long as j is greater than or equal to 2, j is going to decrease. And if is prime of j, so this is our previously identified prime function. If that number is a prime, our largest prime will be equal to j, and then we can break this loop. So we're simply just trying to find the largest prime number that is going to be strictly less than bound. The reason we use bound minus 1 is because we want to find the number that gets bound to be the smallest. And if we do, if the largest prime number is bound, we can't subtract bound from bound, that'll be 0. We want bound to be at least 1. So after that loop, we can then subtract the largest number from our nums of I. So nums of I is going to minus equal our largest prime. And that's it. Then we can return true. The only time where we would return false is if bound is ever less than or equal to 0, meaning that it is impossible for this function to create a strictly increasing array. So if we run this, it passes our test cases, and if we submit it, it passes all solutions. Thank you, and follow for more daily LeetCode solutions.